Welcome back, everyone. So let's quickly prove the law of trichotomy. So first, the definition. So A and B are cuts in Q, then A is less than or equal to B if and only if A is a subset of B, and A is greater than or equal to B if and only if B is a subset of A. Okay? So that's kind of familiar notation to real numbers, and that's exactly why, that's exactly how we're transitioning from Dedekind cuts to real numbers. And we're showing that they're, well, uh, we are thinking of them as synonyms. So now we want to show that given any real numbers A and B, in other words, Dedekind cuts A and B, A is less than B, A is greater than B, or A equals B. Okay, so we're going to take a different route to showing this. We're going to show that it's not possible for an element to be in A but not in B, and vice versa. In other words, show, so by way of, well, okay, let's just say by way of contradiction, suppose there exists, let's see, I guess, yeah, we can use there exists A prime, not, there, let's see, there exists, yeah, there exists a, there exists a, uh, a, sorry, what am I saying? There exists an A, with A is not in B, and, this is key, and there exists B in A, in B, with B is not in A. Well, visually, what does this kind of look like? We're not going to use this for the actual proof, but just to get an idea, that would tell us that the, let's see, the Dedekind cuts would look kind of something like this in the, well, this is like the Q-axis, I guess you could say. That tells us that, well, this, what does this first line say? By way of contradiction, suppose there exists an A. So let's say this is A, this is B, so there exists A in A, but A is not in B. So like something like that, right? Let's say that's A, and then there exists B in B, but with B is not an A. So that's something like that. Okay. Well, we want to show that that is not possible. And then that it would directly follow that it would have to be either of these three cases, right? This is the kind of lesser known proof technique, but it can actually be very powerful. So, well, okay, we have this. Well, what does this tell us? A is not a member of B. Well, in the previous, like 2 videos ago, right, we showed that if A is not a member of B, then A is an upper bound for, it's an upper bound for B, okay? And then it also holds that B is an upper bound for A, okay? Well, we can use the fact that Q is ordered. That's one of our axioms, okay? We're not using an axiom for the real numbers, we're using axioms for the rational numbers, which we already have. Okay, therefore, without loss of generality, suppose that B is greater than A. Okay? Well, what does that tell us? Well, by the fact that B, Well, by the fact that B, capital B, is a Dedekind cut, and B is in B, then that should imply that A is in B. But that is our desired contradiction, because we assume that A was an upper bound for B, and therefore A could not be in B, right? Or just look at, yeah, this. So that's a contradiction. And then it follows that these are the only possibilities. Either A is a subset of B is a subset of A, or they're equal. And yeah, that's pretty much it. So I hope you enjoyed that proof. It's quite elegant. It seemed pretty tricky at first, but with that simple trick, that finished the proof. So see you in the next video. And the next video, we're going to look at some of the powerful results of Dedekind or hard work from Dedekind cuts. So see you then.